Hi, welcome to today's lesson. What we're looking at today is similar triangles. Okay, so similar triangles. Now, it would help if you've watched the video on congruency about when triangles are exactly the same, they're congruent. Okay, we can say that all the angles are the same, all the sides are the same size. Now, congruency relies on either side, 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 angle, side, angle, side, angle, side, or right angle, hypotenuse, side. Okay, so those four things. Now, the thing that doesn't allow for congruency is three angles, where three angles are the same. I'm going to draw this freehand, but you're going to get the idea. If I have, for example, a 90-degree angle, all right, and let's say a 30 and a 60-degree angle, that triangle is fine. But if I had something similar, just slightly larger, also with a 90-degree angle, also with a 30 and a 60 degree, okay? Now those two triangles are similar, okay? They're not congruent. You can see they're not congruent because they're not the same size, all right? But if all three angles are equal to each other, so 90, 60, 30, 90, 60, 30, all right? Then the triangles are similar. Now the thing we can say about similar triangles is there's a lot of information. Firstly, we could say that if I was calling this, what did I call this? ABC, ABC, and then I call this one XYZ, right? XYZ, XYZ. Now there are a couple of things that I can say. Firstly, I can say that ABC is an enlargement of XYZ, okay? So ABC, XYZ is an enlargement of ABC, or ABC is an enlargement of XYZ, but an enlargement of a fractional scale factor, okay? So this I can say, let's say that I've doubled this times by 2. So that is double to that, that is double to that, the hypotenuse is double to that. Okay, so XYZ is an enlargement of ABC. The corresponding angles are equal, so angle A, alright, angle A is equal to angle X. That's what I said when I drew it. Angle B is equal to angle Y, 90 degrees, okay, because I drew it like that. And angle C is equal to angle Z. Alright, so corresponding angles are equal. That's one of the things that shows similarity, if you have corresponding angles equal. Alright. The last thing, and this is one of the most important things, and this is where similarity is actually very powerful, is that corresponding sides have the same ratio. So that means, now there are lots of different ratios, not thousands, there are lots of different ratios you can draw from this. I could say the ratio of AB to its corresponding side, XY, is equal to the ratio of BC, the small one, to YZ. Alright? Or I could say AC to XZ is equal to the ratio of BC to YZ. Right? So it doesn't matter what I'm talking about. If let's say this is 2, then this would be 4 if I'm doubling it. If this is 3, then this would be 6 if I'm doubling it. So AB is 2, XY is 4, BC is 3, YZ is 6. I can simplify all these ratios as to 1 is to 2. 1 is to 2. Alright? That's the one way of thinking about it, about writing its ratios. Now, more powerful, I think, personally, because it's easier for us to understand using algebra, alright, is to write them as fractions in proportion to each other. I can say, for example, the small divided by the big, or the big divided by the small, it doesn't really matter, okay, will always equal the same ratio, as long as I'm using the corresponding sides. So AB over his corresponding side, XY, XY. AB is 2, XY is 4, 2 divided by 4 is a half. Alright. Or BC, 3 over 6, a half. Are you with me? Right. So it doesn't matter what side. Now this is very powerful because I can say to you, okay, fantastic. Let's do 2 squared is 4, 3 squared is 9, 4 and 9 is 13, so this is the square root of 13. Alright? If I'm doing Pythag. You with me? So I can say, okay, fantastic. Right, so if this is the square root of 13, how big is xy? Well, all I need to do is I need to go, okay, well, let's put small over big, AB over xy, right, equals, well, I want the hypotenuse, square root of 13, over xz. Right, well, I know that AB is 2, so I know that this equals a half, right, because I can simplify that. And now all I do is I've got this here, which I can then solve as a linear equation to find out how long xz is. That's what we're going to do in the next step. Okay, right. So that's the whole spiel with the explanation. Now let's get on to an example. Okay. This has lots of depth, right? there's lots of times that you're going to be using this to look at different things and to look at different shapes where you can find a similar triangle inside there. Alright, so the example that I've got, I'm just going to draw this freehand. It's nice in the notes. So the EG that I've got ABC, a big ABC, right? ABC, and I've got DE running parallel to BC, DE. So DE is running parallel to BC. Alright, and now that's the first bit. Now let's put in some of the information they give me. They give me AE is 6 centimeters, right? They're giving me DE is 5 centimeters, and they're giving me BC is 8 centimeters. Now, you always need a combination of two corresponding sides. Okay, in this case, I've got DE and BC. They're the two corresponding sides. But they say first show that ABC, the big one, is similar to ADE. Right, I'm going to show it very similar to the way I would do a proof. Okay, a proof for congruency. So, in triangle ABC and triangle ADE. Alright? So in ABC, now firstly, these are parallel, so that tells me a couple of things. Right? It tells me here that there's a corresponding angle and there's a corresponding angle. So those two must be equal. It also says that that's a corresponding angle right and above the line, and then this is a corresponding angle here, right of the transverse above the line. Right, there's two upside down F's. Right, so let's put that into the words and let's put this into a proof. Firstly, let's say something obvious, that A is common to both of them. Angle A equals angle A, common, right? That's my reason. Angle ADE, or ABC, sorry, let's look at the big one. Angle ABC, B, is equal to angle ADE, and the reason for that is corresponding, angles equal, right? Now, ACB, angle ACB is equal to angle AED, also corresponding angles equal, angles equal. Alright, so now I have therefore, triangle ABC is similar, so similar is 1, 2, 3, similar to triangle ADE, and the reason is angle. Right. Now, there are two reasons to proving similarities, either angle, or sides are in proportion. But because I only have one combination of sides, these two, I can't use sides in proportion yet. I have to use angle. Right. So, that's super. That's the first part of the question. The next part, they say find AC. Alright, so if I'm looking for the big one, A to C, this one here, AC, right? Then let's put that on top, just to make my simplification easier, so I don't have to times up by the unknown and divide down by the opposite. So, they say find AC. So I'm going to put the big over the small. Right. Well, AC is what I'm looking for. Now, AC over his corresponding side. Well, it goes from A, which is the same, to C. So the corresponding side must be AE, right, between that angle and the red dot. You with me? That has got to equal the same ratio of two other sides. Well, let's find two other sides. Well, let's find these two I'm given. So the big, BC, over the small, DE. Are you with me? Okay. Well, that's it. Let's find it now. Okay, so AC over AE is 6. Equals BC is 8. Over DE is 5. Okay. Well, this is just an unknown, right? If you want to call it AC, you can absolutely call it AC. Or, to make your working a bit easier, you can call it small a, you can call it small b, you can call it small c, whatever. The technical term, right term would be small b. So let's use small b for that. You'll see that when you get to trig why it's small letter b, not capital letter b. Okay, so how do I get this alone? Opposite divide by 6 is times by 6. So I've got b equals 8 over 5 times by 6. So b equals 8 over 5 times 6 is 9 3/5. 9 3/5. Okay, you can work that out either the long way by hand or you can use a calculator. That's not an issue. The important part is the concept between here. All that I'm doing is I'm setting up the same, with each fraction, the same ratio. So either big over small Or if you wanted to find out the small one, I put small over big. It doesn't make a difference, okay? As long as you're consistent. If I put the big over the small, then I must put big over small, okay? Right, that's it. Now, there's a lot of stuff that you can do with similarity. There's a lot of proofs that you can do with similarity, all right? And there's a lot more working that you can do with similarity. This is the basic idea. Set up the ratios, solve for the unknown, all right? You need to go practice this a little bit to get good at it, to get comfortable with which one am I going to solve for, all right? I would suggest watching this again because it's a little bit tricky and there's much more depth that I should go into, but in a 10-minute video, I can't go into it. All right, so go check this out, watch this again and go try some more stuff, okay? This is fantastic. And remember, I'm here for you.